Tonight, on the Dreamy Physicist, a single raindrop falls. Not here, not now, but light years away, in the hush of an alien sky. What could it mean? This quiet drop, slipping through strange clouds? Hi there. I'm so glad you're here. Close your eyes if you'd like, or just let your mind float gently. Tonight, we begin a journey through oceans that shimmer on distant worlds, through atmospheres we've never breathed, through silence so deep you might hear a thought echo. We begin with a single raindrop. A raindrop forms. Not here, not above your roof or your garden, but far beyond even the furthest star you can name. It begins quietly, a whisper of vapor in the sky of another world. Tiny molecules swirl and cling, drawn together by invisible fingers, softly becoming round, becoming heavy, becoming something that must fall. It waits there, in a sky that doesn't quite look like blue. Maybe it's honey gold. Maybe it's iron gray. Maybe it's not like anything your eyes were made to see. Then it lets go, and you fall with it. The gravity here isn't like Earth's. It's gentler, or stronger, or maybe it holds you with a sideways pull, as though the planet itself spins beneath you like a dream in motion. The air is thick, or thin, or toxic, but you are safe here, floating with this drop as it falls through clouds of methane, or ammonia, or water that once boiled on Earth, but here remains cool. It passes other droplets, some small, some colossal, all of them riding their own quiet arcs toward a place you haven't seen yet. You move slowly. No rush here. The atmosphere is layered like a lullaby, each level more hushed than the last. Light filters in, dim and peach-colored, from a distant red sun, or maybe two suns, dancing together in the sky like old lovers who never let go. Below, something glints. They see, perhaps, but not blue, not salty, not like the oceans you've touched. It could be methane, like on Titan, Saturn's frigid moon, where rivers wind for miles and rain falls from orange clouds. Or it might be lava, slow and syrup thick, on a molten exoplanet so close to its star that even a thought might catch fire. Or maybe, just maybe, it is water, clear, shimmering water, liquid in the right light, the right pressure, the right distance from a kind enough star. This planet might be called Kepler 22b, or TRAPPIST 1e, or something no human mouth has spoken yet. It might be a rocky world with a thin blue ring, a place where winds carry salt across continents, where clouds drift, just like ours, and maybe, just maybe, where life has learned to float, or crawl, or dream. The raindrop strikes the surface, and it doesn't splash. It vanishes into a soft ripple on a lake that doesn't know your name, but has waited eons to receive this single drop. You imagine walking there. You imagine your boot pressing into strange soil, leaving the first human print in dust that has only known starlight. What would the sky sound like? Would wind carry stories? Would birds sing in frequencies your ears can't hear? Or would there only be the soft, endless breath of a planet turning in silence? Astronomers back home sit in quiet rooms, pointing telescopes at the black between stars, looking for shadows, a dimming of light that says something passed in front. A planet, a hint, a world. They listen for wobbles in gravity, for flickers in the glow of distant suns, for chemical whispers in alien atmospheres. They're searching for water, for oceans, for clouds, for rain. Because where there is rain, there might be rivers. And where there are rivers, there might be lakes. And where there are lakes, there might be something more. A molecule that remembers how to copy itself, how to divide, how to feel hunger, or light, or touch. That's what we really mean when we say we're looking for life. We're looking for something that listens, something that knows its own warmth, something that, if given enough time, might look up at its own sky and wonder if it is alone. So you float still at the edge of that lake, on the edge of that thought. The water here might rise and fall with invisible tides, pulled by moons that never show their faces. The currents might carry nutrients from thermal vents below, where heat and salt and the whisper of chemistry begin their old, quiet dance. You can almost see it, the shimmer of potential, like a thought trying to take shape, a cell trying to divide, a spark trying to remember how to become alive. It all begins with water, always water. Even on Earth, life began in the oceans, deep, dark places where heat met salt and time had patience. So if there is water here, falling from the sky, resting in lakes, dripping slowly into porous stone, then there is hope. Not certainty, not yet, but possibility. And possibility, especially the kind wrapped in silence, is the gentlest kind of magic. You are still there, standing beside the alien shore, watching another drop fall. It lands without sound. The circle of ripples glides outward, fading into the stillness. Above you, the sky remains unreadable, but something about it feels known. Not like memory, but like a song you've never heard that still feels like home. What if this isn't the only world with oceans? What if water has found its way to dozens of distant planets, weaving new possibilities with molecules we haven't met yet? What if somewhere, right now, the tide is rising beneath a sky of green? And if there are oceans out there, what lives in them? Long before we dreamed of distant planets, before telescopes reached out like fingers, grasping for the stars, we began to wonder if we were truly alone in the water. You lie still now, wrapped in quiet, as your thoughts drift toward a moon, not ours, exactly, but one that orbits a giant, ringed planet with 1,000 secrets written in cloud. Jupiter watches over many moons, but one of them, small and icy, glows with a mystery that calls quietly across the solar wind. Europa. You drift toward it now, as if your breath could carry you across space. Europa looks like a cracked marble, a sphere of smooth white, edged with long scars, lines where the ice has fractured, healed, and fractured again. It's cold there, colder than anything you felt, yet beneath that frozen shell is something astonishing. An ocean, not just frost, not just dust or dry memories. A true liquid ocean, sealed beneath a roof of ice, up to 20 kilometers thick. Imagine that. A sea without sunlight, without wind, without sky, and yet it moves. The warmth comes not from above, but from within, from Europa's own belly, kneaded and tugged by Jupiter's immense gravity, like dough pressed between planetary palms. This tidal flexing creates friction, and friction gives rise to heat. Enough heat to keep the waters below from freezing solid. Enough heat to let an ocean exist in darkness. And where there is warmth and water, the oldest story begins again. No sunlight penetrates the icy ceiling, but light isn't the only giver of life. On Earth, deep beneath the Pacific, creatures thrive in blackness beside hydrothermal vents that spew minerals and heat into the abyss. Tube worms stretch like crimson trumpets. Blind shrimp scuttle on the floor. Whole ecosystems bloom without ever seeing the sun. What if Europa is the same? What if, beneath its ice, vents crack the seafloor and stir the dark with rich, hot minerals? What if cells form there, simple, tenacious, wrapped in membranes, like tiny, determined dreams? No eyes, no fins, no language, just the first breath of being. You float now, in your mind, beneath Europa's crust. Above you, kilometers of ice. Below, a vast and inky world. The water moves slowly, carrying salt, silicates, traces of carbon. Maybe, even now, plumes are erupting, vents in the ice, shooting briny water into space. The Hubble Space Telescope saw them, fountains of vapor rising from cracks like exhalations from a dreaming sea. We've never touched them, but they reach for us, even from 500 million miles away. Europa whispers, and we listen. NASA plans to send a mission soon, Europa Clipper, a spacecraft designed to circle and scan, to peer beneath the ice with radar and light, to taste the plumes, for salt, for organics, for the unmistakable scent of something alive. You imagine it approaching, its silver hull gleaming against Jupiter's golden gaze. A machine, but sent with longing, built by hands that hope, guided by questions older than fire. Could life begin again in a sea without sky? Europa isn't the only moon that hides an ocean. There are others. Ganymede, Callisto, Enceladus, moons with crusts of frost and hearts of liquid. But Europa came first, the first ocean beyond Earth that made scientists stop and shiver and wonder. And when you wonder, truly wonder, you open a doorway in the mind where dreams and evidence hold hands. Europa's surface is silent, but the sea below may be churning, and in that churning might be a memory of how life once began on Earth. We call it abiogenesis, the beginning of living things from lifeless matter. A word so long, yet so soft when whispered before sleep. It might have happened more than once, not just here, but there. You imagine the first stirring, a molecule that folds, a chain that repeats, a bubble that traps warmth, and then something moves, not fast, not loud, just enough to mean, I am. You float through that ocean now, feeling its cold against your thoughts. Not empty, not hostile, just unknown. Would we recognize life if we saw it there? On Earth, life uses DNA, a code of letters, folded in on itself like a library inside a whisper. But on Europa, life might write with different ink. Maybe it uses something else entirely. Chemicals we've never tasted, shapes we've never mapped. Would we even know we were looking at something alive? That is the risk of wonder. It might surprise you. It might change what you thought life could be. You imagine dipping a hand into Europa's sea, not to conquer, but to feel, to touch the ancient cold and ask, not with words, but with silence, are you there? And perhaps the sea answers, not in sound, not in waves, but in the way a thought rises in your chest, unexpected, weightless, true. If we find life on Europa, even the simplest kind, it means we are not alone. Not because someone else is watching, but because the universe knows how to build breath from stone and time and water. If it happened twice, here and there, then maybe it has happened everywhere. You lie still now, with that thought resting just behind your eyes. The ocean below Europa is still flowing, still whispering through cracks, still sending plumes into the dark. We are listening, and soon we may touch what lies beneath. You close your eyes again, and the ice begins to dissolve, not melt, just gently vanish into something even more ancient. The ocean beneath Europa fades, and your thoughts drift outward, searching for something deeper still, a world so drenched in water that it never knew the dry sting of sun. Imagine, for a moment, a planet without continents, no ridges, no deserts, no mountains stretching skyward, no dust swirling in the wind, only ocean, from pole to pole, wave to wave, a single, boundless sea with no shore to break it. This is not fantasy. Astronomers call them ocean worlds, and some may be far more water-rich than Earth has ever been. You flow toward one now. The stars remain hushed. The dark between them breathes slowly, and somewhere in that darkness, a blue world spins. Not pale blue like Earth, but deep and endless. A sphere of sapphire and shadow, a sea wrapped in sky. It may orbit a dim red star, cooler than our sun, but long-lived, a patient flame that gives its planets time to dream. These ocean planets may form farther from their stars, where ice is plentiful, but over eons, gravity gathers warmth and ice turns to sea. Sometimes their water may stretch hundreds of kilometers deep, not a few miles, like Earth's deepest trench, but thousands of miles of open blue. Can you feel it? You, floating just above its endless surface, no land in sight, no place to anchor, only rolling waves beneath a distant sky. Beneath you, the water may be layered. The top, a sunlit shimmer, bathed in faint starlight. Below that, a twilight zone. Dim, still, quiet. And beneath that, a pressure so great it turns water into something strange. At those depths, the pressure is enormous, so high. It crushes water into high-pressure ice, not the kind you skate on, but a solid that forms beneath the ocean, like a hidden floor. This means, on these worlds, you can have a sea with no rocky bottom, just water atop ice, atop water again. And yet, life may still exist, even if no sun warms the waves, even if no land breaks the tide. Life finds a way. If hydrothermal vents exist on these planets too, spewing warmth and minerals from deep within, then life could stir in the dark, tiny cells drifting through the depths, perhaps glowing faintly or feeding on chemical currents. Entire food chains without a single leaf or ray of sun. And maybe, just maybe, they swim in groups. Maybe they seek each other out, like echoes of a deeper instinct, the need to connect. Now imagine this world evolving, not just for years, but for billions of orbits. Waves rise and fall, currents churn and mix, and life, slowly, quietly, diversifies. Without land, there are no forests, no birds, no cities, but perhaps there are reefs, fields of drifting tendrils, creatures shaped by flow. A kind of intelligence could even emerge, not with fire, not with tools, but with communication made of pulses, light, vibration, electric fields in salt water. What might consciousness look like when shaped by ocean? On Earth, the octopus learned to solve puzzles. In the deep, dolphins sing names to each other, and whales compose songs that carry across oceans. What songs might arise on a world where the sea never sleeps? You drift deeper now into this imaginary ocean, and you begin to feel how different this kind of life would be, how adaptable, how fluid. They would never know lightning, never climb, never burn wood or build machines. But they might understand patterns. They might remember past knowledge, gather in vast drifting swarms to witness a passing comet reflected in the rippling sky above. Would they look up, as we do, and wonder what lies beyond? Or would they look down into the depths, seeking warmth at the roots of their world? You feel the weight of the sea around you. It does not drown. It cradles. It silences some questions and amplifies others. Where we build cities, they might build colonies of light. Where we speak in air, they may sing in liquid. But the ache to understand, that might be the same. And maybe that is the true sign of life, not cells or movement or even reproduction, but curiosity, the longing to know what is. Perhaps these ocean beings don't just drift, they explore. Maybe they've sent something upward, a bubble machine, a shell-like craft, rising toward the stars to taste the void. And maybe, from their distant home, they've heard whispers, radio waves, leaking from Earth like forgotten songs. Maybe, for them, we are the strange ones, creatures who left our oceans and walked on dust, creatures who build flame and steel and machines to cross the stars. They, born in water, could never imagine fire, just as we, born on land, struggle to imagine an endless sea. And yet, here we are, dreaming of them. You float once more above that alien tide, feeling its rhythm in your chest. It is different and yet familiar because Earth, too, was once like this before the continents rose, before the crust cracked and mountains heaved. We were once only water, and maybe deep down we remember in our blood, in our breath, in the salt that runs through us. We are children of the sea, even here on land. So when we dream of ocean worlds, of planets that never knew the crunch of stone or the burn of sun-dried sand, we are dreaming backward to the womb of being. And in that quiet remembering, a new question begins to rise. What happens when land finally appears? What if one of these ocean worlds gives birth to islands? A crack in the crust, a plume of rock, a first rocky shore, and with it, the chance to walk. You drift once more among the stars, your thoughts still damp with the memory of endless oceans. In the last world you visited, there was no land, only water, deep and uninterrupted, a blue that wrapped the entire globe in silence. But now, something shifts beneath you, not a wave, but gravity. Pull, a pulse, a presence. You arrive at a new kind of world, heavier, broader, stronger than Earth, yet strangely familiar. They call it a super Earth, not because it is more advanced, not because it is heroic, but because it is more massive than our home. Not a gas giant, not a little rocky Mars, but something in between. A planet of stone and soil, perhaps, or ocean and cloud, but scaled up. Imagine Earth, but 1.5 times larger, twice as wide, 5 times heavier, with mountains that never sleep and seas that sigh more deeply. Here, gravity tugs a little stronger. Your body would feel it. Your bones would bend to it. Your breath would fall heavier in your lungs. But your feet, oh, your feet would feel safe, anchored, as if the ground meant every word when it whispered, stay. These planets are scattered across the galaxy. We find them often because they speak louder in the data. Their size tugs more firmly on their stars. Their presence dims the starlight more clearly when they pass in front of it. And what's more, many of them lie in the habitable zone, that quiet band where liquid water might pool, where warmth is just enough to hold oceans on the edge of possibility. But what would it feel like to stand on one? Close your eyes again. Picture yourself on the shore of a super Earth. The sky is familiar, perhaps blue, perhaps lilac, with clouds that curl in shapes unknown. The sea moves slower here, heavier under stronger gravity. Waves rise, but do not leap. They roll in steady rhythm, like the breath of a patient sleeper. There may be islands, tall and sharp, formed by tectonic forces, more powerful than Earth's. Maybe volcanoes pierce the sky with columns of vapor, feeding clouds that last for centuries. And beneath that surface, a crust thicker than ours, stretched but not broken, solid and strong. This stability, this weight, might help life take hold. Less chaos, fewer sudden shifts, slow simmer of chemistry and time. And time. Oh, how it flows here. Planets like these may last longer than Earth. Their larger size lets them keep their molten cores warm for eons. And with a molten core comes something essential, a magnetic field, that unseen blanket that shields a world from the harsh breath of solar wind. On Earth, this field dances in auroras, protects our atmosphere, holds our air in place. Without it, a planet is stripped bare. So if these super Earths have strong, living cores, they may guard their skies like sacred breath, and their skies may be thick with cloud or thin with clarity. We do not yet know, but we do know their gravity shapes the world deeply. It holds on to more atmosphere, lets fewer gases escape, and that changes everything from weather to erosion to the way sound moves through the air. Would voices carried differently here? Would music sound slower, deeper, softer? Would a creature evolved under such pressure have lungs the size of drums? Would flight be possible at all? Maybe wings would stretch wider, flap slower, built to push through denser sky. Or maybe no flight exists at all, just song, just stillness. But don't be fooled by their size. Some super Earths are not land-bound at all. Some may be entire ocean worlds, like the ones you visited before, but deeper, faster, more alien. Imagine an ocean 10 times as deep as Earth's Mariana Trench, resting on a planet twice Earth's width. Imagine the pressure, the chemistry, the patience. What quiet creatures could endure such weight? Some scientists think these oceans might become too deep. That pressure might lock them away from geology, from the churning crust below that feeds life with nutrients and heat. But others think a delicate balance could form, that subtle waves of heat and salt might rise even in these crushing depths, that life could flicker like embers in the black. And what of the sky? You wonder as you imagine yourself floating in the air above this world. Would clouds form in layers? Would rain fall more slowly, drawn downward by gravity's greater pull? Would lightning crack the silence with the same white fire? Or would storms move with thunderous grace, like the groaning of mountains? Perhaps the entire weather system is deeper, denser, more enduring, not the flash of our summer storms, but centuries-long tempests, spinning quietly, patiently, with no need to hurry. There is a kind of wisdom in slow motion. You might not see it at first, but you feel it in the way a single drop falls and reshapes a canyon, not in minutes, but millennia. Maybe life on super Earths learns this patience, grows into it, learns to endure and adapt to the weight of its own world. Maybe intelligence blossoms here, not in quick sparks, but in long burning coals, not in fire, but in warmth that lasts through ice ages. And just maybe, beneath that patient surface, beneath the subtle waves and silent winds, something watches the sky and wonders, like we do, because the questions we ask may not be ours alone. And tonight, as you float away from this heavy, beautiful planet, one question lingers. Not can life exist here, but what kind of story would it tell? What memories would be written in salt and time? And as you drift onward toward smaller, colder worlds, you begin to feel the pull of something distant, a moon, half rock, half ice, holding a secret sea beneath its frozen face. You drift again, weightless and wondering, across the quiet dark between stars. Behind you, the heavy hush of super Earths still echoes in your thoughts. Worlds thick with pressure, with patience, with waves that moved like memory. But now you're pulled inward toward something colder, smaller, yet hiding a warmth no one expected. It doesn't shine. It doesn't shimmer. From a distance, it seems like a frozen moon, locked in the orbit of a much larger planet. But as you draw close, you sense something stirring beneath the ice. This is Europa, a tiny world, just one of Jupiter's many moons, but one that holds a secret sea. Imagine this, a world with no sunlight, no soft wind, no trees, no sky, just a shell of frozen water, so thick, so ancient, it could shatter steel with its quiet weight. And yet, beneath that shell, a global ocean waits. Not a lake, not a sea, but an entire world of water, moving in silence. It was once thought impossible, too cold, too distant, too dead. But warmth, it turns out, does not only come from stars. Deep inside Europa, the tug and twist of Jupiter's gravity kneads its core like bread. This process, called tidal heating, creates friction, and friction, in the language of worlds, means warmth. Enough warmth to melt ice into liquid, enough warmth to stir water into motion, enough warmth to sustain a slow breathing sea for billions of years. And within that sea, strange things might rise. You can't see them, not yet. The ice above is too thick, like a lid on a dream. But imagine swimming there, not in open sunlight, but in dimness, in silence, in pressure. And yet, it's not empty. Yeah. In that underwater darkness, clouds begin to form. Not clouds in the sky, but hydrothermal clouds rising from vents on the ocean floor. Just as on Earth, where black smokers release heat and minerals into our deep sea trenches, Europa may have them too. Imagine the sea floor, etched with fractures, where the crust of ice meets a rocky core. From these cracks, columns of warm water rise, rich in hydrogen, carbon, iron, ammonia, chemical seeds. And as these warm plumes bloom upward, they meet the cold water above and cool into gentle clouds, not of vapor, but of mineral, of life's ingredients gathered slowly like stories in the dark. You float beside one now, a pale cloud, curling slowly like smoke beneath the sea. Here, without sunlight, there is no photosynthesis, no green leaves, no sun-fed cells. But life, if it is here, might feed instead on chemosynthesis. It's a quieter kind of hunger, drawing energy not from light, but from chemistry. Sulfur, methane, hydrogen sulfide. This is the diet of Earth's deepest creatures, the ones who thrive in darkness. And maybe Europa, in its infinite hush, breathes in a similar way. Maybe, floating in those clouds, are single cells, older than memory, or maybe more. Colonies, ribbons, filter feeders, drifting with the current. Tiny jelly lights that pulse with heat, worms with no eyes, but perfect maps of pressure and vibration. Creatures not shaped by seasons or sky, but by warmth and salt and stillness. And how would they move? Not in bursts, but in sways. Not in escape, but in flow. Perhaps they rise with the clouds, sink when the clouds dissolve, living their lives in these warm underwater weathers. And maybe, just maybe, intelligence does not need sunlight either. Maybe thought can form in the slow pattern of chemical tides. Maybe memory can live in how the clouds drift or how the minerals gather. And if they do not speak, maybe they listen to the ocean's heartbeat, to the pulse of the vents, to the tremble of far-off ice quakes echoing above, because ice, too, is alive in its own way. Europa's frozen crust cracks and groans like a sleeping giant, pulled and flexed by Jupiter's might. Sometimes it fractures, sending geysers of water shooting into space. And in those geysers, we found traces, tiny hints of salt, of organics, of hidden processes. They're just whispers, not answers. But they tell us that Europa's ocean is not still. It churns, it breathes, it speaks in minerals and motion. And you're listening. Imagine living not on a planet, but within one, not on its surface, but in its hidden sea, never seeing a star, yet never knowing night. A world where clouds form below, not above, where rain rises, not falls, where warmth does not glow, but flows. Would such life ever reach the ice above? Would it try to break through? Or would it remain content, always swimming, always dreaming, beneath? And what would such beings think if one day a strange machine arrived? A probe, a robot, a visitor from light. Would they recognize it as alive? Would they fear it, or welcome it, or ignore it like a drifting stone? These questions are vast, but their beauty is in the asking. Because Europa is not alone. There are other ocean worlds, moons with ice, with tides, with secret seas. And so, as you float upward toward the crust of ice and the stars beyond, you carry with you the stillness of Europa's clouds, their weightless drift, their chemical song, their patience. But ahead, something colder waits. distant moon, larger and stranger, where methane reigns, and lakes stretch under an orange sky. You turn toward it now, curious and calm, ready to listen again to what lies beneath another kind of sky. The stars above remain unchanged, but your thoughts drift now, deeper still, into the hidden hearts of ancient moons. You've left Europa's clouded sea, its warm breath beneath frozen armor, and now you sail farther into the outer dark, to moons older, colder, but whispering just as softly. These are not places of roaring storms or glittering skies. They are quiet, dim, wrapped in crusts that shimmer with frost and secrets. They do not call for attention, but they listen. You arrive near Enceladus, a small moon of Saturn's vast family. At first glance, it seems like any other frozen sphere, but beneath its snowy surface, something remarkable stirs. You pause, hovering. Your senses adjust to the pale glow of Saturn far in the background. The silence feels absolute until you see it. A geyser, then another, and another. Jets of water shoot from cracks in the moon's south pole, arching into space in delicate plumes. They rise like breath, carving trails through vacuum, leaving behind particles of ice, grains of salt, and hints of life's building blocks. These are not just eruptions, they are messages. Enceladus is speaking, not in words, but in minerals, sodium, carbon, hydrogen, and something stranger still, organic molecules. It's as though this little moon has flung open its window, letting its deep ocean exhale into the cold. And you wonder, how deep does that ocean go? Beneath the ice shell, a vast sea swirls, perhaps global, perhaps only tucked beneath the southern crust. And just like Europa, it is warmed from within, not by sunlight, but by the push and pull of Saturn's gravity. Tidal heating, again, the silent friction that turns motion into warmth. And in that warmth, salts dissolve, minerals mix, and chemistry begins. Salty water is not just a sign of past oceans. It is a recipe. On Earth, life began in salty water. It still clings to it, needs it, carries the memory of it in every cell. Your body, right now, holds ocean within, plasma, sweat, tears, all salty echoes of an ancient sea. So when Enceladus sprays salt into space, it's more than geology. It's an echo of something familiar, something close. And yet, this ocean has never seen light. Its salt has never touched shore. But still, the geysers tell a story. They rise through cracks, called tiger stripes, dark bands on Enceladus's skin, stretching and contracting with the moon's orbit. Through these cracks, the water escapes, and with it, secrets. We've flown spacecraft through those plumes. We've tasted their mist with robotic tongues and found compounds we know well: silica, ammonia, carbon dioxide, simple organics like methane and formaldehyde. And though these are not proof of life, they are whispers, possibilities. Because salt water can host more than salt. It can cradle enzymes, fold proteins, build membranes, the scaffolding for something that moves, that divides, that remembers. And so you imagine what swims below. Not fish, not whales, not stories from Earth's ocean, but something suited to pressure and shadow. Something that reads temperature like we read light. Perhaps microbial mats cling to rock where minerals bloom. From hydrothermal vents, perhaps there is chemistry quietly stacking possibilities, just as it did on Earth 4 billion years ago. Or perhaps it is still waiting, still stirring, still dreaming. And Enceladus is not alone. You turn now, drifting farther into the Saturn system, toward another moon with secrets in its soil. Mimas, smaller, rounder, often ignored. To many, it looks like a cratered marble, lifeless, pocked, a frozen relic. But even here, there are whispers. Its surface is still, but its orbit wobbles in a way that suggests liquid within. Perhaps a buried ocean, quiet and still. Or perhaps only patches, hidden pockets of salt water beneath the ice. And then there is Titan, not an ocean world like Europa or Enceladus, but with a chemistry all its own. Titan's surface is not made of water. It is far too cold. Instead, rivers and lakes of methane carve its plains. Rain falls from orange clouds. Dunes of frozen particles whisper across an alien landscape. But beneath that crust, deeper still, scientists believe a subsurface ocean exists. A mix of water and ammonia, an antifreeze blend, kept warm by tidal forces. And ammonia, in the grand puzzle of life, can act as a solvent, a messenger, a matchmaker. Could life arise in such strange waters? Would it need membranes? Would it breathe? Would it think? Or would it simply exist as chemical poetry, shifting, interacting, becoming? And how would it taste? The world above? Would the cracks in the ice let signals pass through? Would it feel the weight of Titan's methane rain? So many questions, so few answers. But in these moons, salt is more than seasoning. It is a sign of movement, of mixing, of possibility. Salt keeps water from freezing. It conducts. It connects. And just like on Earth, where salt water moves in tides and cycles, so might these alien oceans pulse in rhythms we do not yet understand. You imagine a deep ocean current on Enceladus looping slowly for centuries. You picture minerals falling like snow, settling into patterns. You hear silence, but it is not empty, it is full of waiting. And now, as you rise once more from the icy moons, your thoughts stretch forward, out past Saturn, toward Uranus and Neptune, where other moons hide in shadow, moons like Triton, strange, captured, and perhaps holding oceans too. You wonder how many more worlds keep their seas inside? How many other salty secrets wait beneath shells of ice, and as the stars whisper overhead, you feel the tug of something ancient, the sense that life may not be rare, only shy, only hidden, only waiting for someone patient enough to listen beneath the silence. In the quiet deep, far beyond Earth, there are oceans sealed in shadow, where no sky has ever been seen, not even once, not even in memory. You float now in that thought, adrift in an ocean that belongs to a world of ice. Not a drop of sunlight has ever reached these waters, and yet they may be full of life, not life that sees or hears the crash of waves, but life that pulses, that breathes in chemistry, that thrives in the warmth of stone. Let's begin with Europa, a moon of Jupiter. It is small, icy, etched with long scars from a crust that shifts and groans. Under that crust, a secret sea, a global ocean wrapped in darkness, kept warm not by a sun, but by the pull of gravity itself. Jupiter's massive tug stretches Europa's insides, rubbing rock against rock, creating friction, heat, and a slow churning deep below. The ice on the surface may be 10 miles thick, but beneath that frozen roof is liquid water, more of it than in all of Earth's oceans combined. In that buried sea, hydrothermal vents might rise from the ocean floor, spewing warmth and minerals like undersea fireplaces. And where there is warmth and minerals and water, there might be life. On Earth, hydrothermal vents are crowded with life, strange creatures that need no sunlight. They thrive in utter blackness, living off chemistry instead of light. Tube worms, blind shrimp, bacteria that eat sulfur, worlds within worlds in our own oceans. So what about Europa? Could it, too, harbor creatures that never saw the sky? Not fish, not dolphins, but simple forms, cells that split and grow, that float and feed in a rhythm shaped by heat. They would never know stars, never dream of constellations, but they might still sense the world through warmth and motion, through pressure and flow. Imagine being one, a tiny drifting cell, suspended in thick black water, feeling the nearby warmth of a vent, following the trace of nutrients, like a whisper in the dark. You have no eyes, no ears, no language, no need. The ocean is your entire reality, and in that reality, you are complete. Europa is not alone. There's Enceladus, a tiny moon of Saturn. It's smaller, colder, but not silent. From cracks near its south pole, it sprays water into space. Geysers made of ice and vapor, spraying from an inner ocean. When NASA's Cassini spacecraft flew through the plume, it tasted salt and simple organics and silicate grains, the kind you'd expect from warm rock and water interacting below. And so, Enceladus, too, has what life might need: heat, water, and time. Not hundreds of years, not thousands, but billions. Time enough for molecules to find each other, for patterns to emerge, for life to try and try and try again. But here's the thing: these worlds are closed, locked in, skyless, timeless, no seasons, no sunlight, no stars to guide migration, only internal tides, gentle thermal pulses, slow and quiet, like a lullaby without sound. Life in these seas would never see a tree, never hear a bird, never feel the sting of wind or the warmth of sun, but they wouldn't miss it because they wouldn't know it. For them, the ocean is all, and all is enough. They might feel the world the way you feel music through your chest, not in sight, but in vibration, in gradients of warmth, in chemical trails. Their maps are not of stars, but of minerals, of flow, of rhythm. They may pulse when the ocean shifts, cluster where the heat is strong, drift when the current turns cold. They would not be lonely. They would not dream of more, because they are exactly where they belong. We often imagine alien life as creatures like us, eyes, hands, voices, desires. But life, in its simplest form, needs none of these. It needs only to persist, to hold its pattern just long enough to pass it on, to continue in the dark, to be what the universe allows, and perhaps what it prefers. Because for every world like Earth, with sky and storm and breath, there may be 10 with oceans locked beneath ice. 10 quiet places where sunlight never touched the sea, but where warmth from inside never stopped flowing. Think of that. Think of a galaxy, not glowing with cities or signals, but humming softly with undersea hearts. Tiny worlds, tucked beneath ice sheets, alive with motion, too small for our telescopes to catch, but not too small to matter. Because life, even the simplest, even the blindest, reminds the universe that it is not alone. And if these alien seas do hold life, then somewhere right now, a cell might be dividing, sending itself forward into a future it cannot imagine. No sky, no stars, no fear, just chemistry and warmth and flow. Just one more moment of being. And that, even in the dark, is something beautiful. Before there is water, there must be silence. Before there is an ocean, there must be pressure and patience and time to build an alien ocean, one that will never kiss the sky, never greet the sun. You begin not with waves, but with ice, thick ice, cold beyond the imagining, but not still, not lifeless. You start with a world far from its star, where sunlight is a rumor, where distance stretches like a winter that never ends. A moon, perhaps, or a dwarf planet shaped by gravity and shadow. You need a crust of water ice, the kind that forms not from oceans freezing, but from oceans never melting. Water, after all, is everywhere, locked in comets, hidden in dust, woven into the fabric of planets. The ingredients are not rare: hydrogen, oxygen, heat, and time. They combine in the cold nursery of a forming solar system, drifting among rocks and rings, waiting for gravity to sculpt a sphere. That sphere, Europa, Enceladus, Ganymede, Titan, forms in deep freeze. But something stirs inside. Not a spark, not a flame, but a slow kneading from within. Tidal flexing, that's the phrase scientists use. Imagine a rubber ball squeezed and released over and over by a giant invisible hand. That hand is gravity, and the one who squeezes is often a nearby giant, like Jupiter or Saturn. As the moon orbits, its insides stretch, contract, twist. This movement creates friction. Friction creates heat, and heat melts the ice beneath. Not on the surface. It's too cold for that. But deep inside, the ice turns to water, and water begins to flow. Now you have the beginnings of an alien ocean. It won't shimmer blue, it won't cradle boats or scatter light. It will be black, still heavy with salt and rock-borne minerals. But it will be real, it will be vast, and it will never have seen the sky. The next ingredient is a boundary. Oceans need walls. They need containers. On Earth, the ocean is pressed between the air above and the rock below. But here, on an alien world, the sea is trapped between ice above and rock beneath. Think of it like a giant sandwich. Ice crust, liquid ocean, rocky core. That crust may be miles thick, a frozen ceiling that protects the sea from the silence of space. But it's not perfect. Sometimes cracks appear. Sometimes plumes erupt. Sometimes the ocean speaks. These are the moments when we, from Earth, catch a glimpse. We see geysers erupting from Enceladus. We map red streaks across Europa. We analyze the chemistry of clouds, and we guess. We wonder. We calculate pressure and salinity and temperature gradients across invisible waves. Because building an alien ocean is only half the story. The rest is understanding what might live there. First, you need heat. The ocean must stay liquid for millions, even billions of years. Tidal heating helps. So do radioactive elements deep in the core. A slow burn, constant enough to keep the water from freezing solid. Then you need ingredients: carbon, nitrogen, phosphorus, sulfur. On Earth, these come from the land, washed into the sea by rain and rivers. But what about a world with no sky, no rivers, no rain? Then the ingredients must come from below. Hydrothermal vents, cracks in the rocky seafloor, where heat and chemicals pour out like breath from the planet's lungs. Here, in these alien seas, vents may bubble and hiss into black water. Iron and sulfur swirl like ink. Molecules break, combine, reform. And from that soup, something stirs. Not a fish, not a brain. Just chemistry, trying itself out again and again. Because that's what life is. Not a miracle, but a process. One molecule bumping into another at just the right angle, in just the right place, with just enough energy to do something unexpected, to copy itself, to hold a pattern, to become something more. And in that slow birth, a new ocean becomes more than water. It becomes alive. But would we recognize it? Would we call it life if it doesn't breathe like we do or think? or dream? Would we know it if it swam silently in the dark, never once looking up? Because there is no up on earth. We're used to life that reaches toward the sun. But in these oceans, life might reach inward, toward warmth, toward chemistry, toward survival. Some models suggest these alien oceans might be layered. A dense salty sea below, a fresher layer above. Each layer a different world, each layer a different rhythm. Currents may rise and fall without wind. Tides may pulse to a hidden beat. Perhaps life there is stratified, some floating near the ceiling, others clustered near the warmth below. Perhaps they migrate, not by season, but by salinity. Perhaps they sing in gradients of sulfur. We can only guess, but even our guesses shape the questions we ask. And the questions lead us closer to understanding how nature builds possibility out of pressure and patience. To build an alien ocean, you don't need a sky. You need time. You need balance. You need a planet that listens to its own gravity and answers with warmth. You need a sealed room where light has never been, but life might still knock softly on the walls. And perhaps one day we will knock back, drop a robot through the ice, watch it swim into that ink black sea, listen for signals in the silence, not to disturb, not to conquer, just to witness, because to see an alien ocean is to remember how many stories the universe is still telling, and we are just now learning to listen. There are oceans that never see their stars, and stars that cradle their oceans from a distance. But somewhere in between, not too far, not too close, there is a warmth that doesn't scorch, a distance that doesn't forget. In that quiet space, wrapped in light, but not devoured by it, currents begin to stir. You are standing now, in your imagination, on a world you've never seen. It circles its sun in a slow, gentle rhythm, neither shivering nor burning. The light here is golden, but softer than Earth's, filtered by clouds you've never named. Its sky might be pink or copper or layered in haze, but below that sky there is water, not buried, not frozen, not locked beneath a crust of ice. Here, the ocean breathes. It is wide. It is open. It dances under light that touches it every single day. This is what Earth knows. But Earth is not alone. Astronomers call them exoplanets, worlds beyond our solar system. And some of these, with just the right conditions, could cradle oceans on their surface. Liquid water beneath a sky in a star's embrace. To find them, we look for the habitable zone, not too hot, not too cold, the celestial Goldilocks band around each star. Not every star is the same. Some burn blue and fast, too bright, too brief. Others glow red and slow, small but steady. A red dwarf star, for example, is cool and dim, but if a planet hugs it close, it might just stay warm enough to host an ocean. That ocean would not be like Earth's. Imagine a tide controlled not just by a moon, but by the very breathing of the star itself, its flares, its rhythms, its magnetic heartbeat. The water could glow at night if bioluminescent life has learned to sing in ultraviolet. It could be calm, a mirror to a crimson sun, or stormy, churned by winds we do not yet understand. But the most important thing about these oceans is that they are open. They see their star. They feel it. They change because of it. Currents form because warm water rises, cool water sinks, because heat is uneven, because motion follows light. This is how oceans breathe, not lungs, but loops. Circulations that carry nutrients, energy, possibility. On Earth, these loops move heat from the equator to the poles. They bring food from the deep to the surface. They shape the climate. They shape life. Now picture this: an alien planet, tilted just so, spinning once every few days. Its ocean deep, wide, and wild. Sunlight warms its equator. Currents rise, swirl, drift toward colder latitudes. Winds, if they exist, skim the surface, dragging the top layers in great gyres. Below, something stirs. Maybe it's chemistry. Maybe it's life. These currents don't just mix water, they mix history. Every molecule of water has a memory: where it came from, what it touched, how long it's danced in the heat of its star. And when these waters move, they carry the whispers of 1,000 sunrises. Some exoplanets might be locked in synchronous rotation, one face always toward the star, the other in endless night. On such worlds, the ocean becomes a conveyor belt of warmth. It shuttles heat from the light side to the dark, carving a habitable band between two extremes. A place of twilight, a place of balance. Here, currents may be the reason life can hold on at all. And what of the chemistry? Every star has a recipe, and so does every ocean. It warms. The starlight carries different colors, different energy. Some stars bathe their planets in more infrared, others in ultraviolet. This changes everything. Photosynthesis, if it evolves, might not use green. It might use black, or purple, or hues we have no name for yet. And if life forms that feeds on sunlight, it will ride those surface currents like seeds in the wind, carried from sunlit shallows to deeper stillness, then up again. A rhythm of motion, not just of survival, but of experience. You see, on worlds like these, currents are not just water. They are stories. They are threads that connect place to place, warmth to cold, surface to seafloor. They are the memory of a star's presence etched in liquid form. And in that movement, life can arise, not as a sudden miracle, but as a dance, complex, patient, full of longing. Because water that moves does more than exist. It explores. And maybe, in some corner of that sea, a creature stirs, soft-bodied, slow, feeling the difference between morning and night, not in light, but in temperature. It feels the tides, the slow turn of a planet beneath a star. It doesn't think like we do, but it notices and it responds. This is how it begins, not with intelligence, but with awareness. And what are we, if not awareness, sailing through time? These oceans, these alien seas, held in a star's quiet arms, may be full of such beginnings, of motion that leads to memory, of warmth that leads to thought. And we're just beginning to understand what a sun can teach, a planet's heart. You don't need Earth to create a world of wonder. You just need light and water and movement and time. Time to let the dance begin. Time for the ocean to find its own rhythm beneath the gaze of a gentle star. Water is gentle, you think. Cool, clear, a balm to flame. But on other worlds, water has learned to play stranger roles. There are oceans that scald, lakes that steam, and glaciers that crawl like rivers without ever melting, because not every world follows Earth's familiar script. You and I, we walk on a planet where water turns to vapor at a boil, to ice when cold, and stays between in a dance we've come to know as life. But out there, in the starlit dark, water wears more than three faces. It whispers through superheated clouds and creeps in solid form along the bellies of frozen moons. Let us drift now to a place not far in light, but far in feeling. Jupiter's volcanic moon, Io, not known for its water, but for its fire, sulfur fountains, lava plains, tortured world kneaded by tidal forces, as if the giant planet grinds it like dough. But go just a little farther, and you'll reach Europa, a world encased in ice. Beneath it, an ocean, liquid, warm, moving. Why? Because gravity, like a patient hand, presses and flexes. Jupiter's pull is not gentle. It stretches Europa in rhythmic pulses, friction heating its core from the inside out. There, beneath a crust of frozen silence, the water may burn with unseen energy, not flame, but hydrothermal heat, vents that bubble, chimneys that rise from blackness. On Earth, such places are alive. Creatures gather at the feet of fire that never saw sunlight, nourished not by sky, but by chemistry. Could Europa be the same? Could water that never meets air still birth something warm? Now imagine water on a super Earth, heavier than home, gravity thick as syrup, pressure immense. Here, oceans don't end in sky, they end in ice. Not the kind you know, but a new phase altogether. Scientists call it Ice 7, a form of solid water so dense it forms under pressure instead of cold. Picture this. You dive into an alien sea, swimming deep, deeper still, until light vanishes and heat remains. At a certain point, the pressure crushes water into solid, yet the sea remains above it, flowing, a floor of ice, not formed from freezing, but from gravity's grip. Ice that flows like stone and burns like friction when it moves. Or turn your gaze to hot Jupiter's giant worlds hugging their stars. Their skies churn with vaporized metals, and their water, if it exists, boils into the atmosphere as a constant breath. That clouds of water may swirl in temperatures hotter than ovens, shimmering with the memory of oceans long evaporated, but in the right place, on the cooler backside of a tidally locked planet. That vapor may condense again, forming lakes that sizzle and rains that hiss when they fall, burning water, not in flame, but in temperature, too hot to touch, too dense to breathe. And on icy moons, like Saturn's Enceladus, jets of water erupt from cracks, freezing in space into ribbons of snow that fall back like whispers from the void. That ice, though frozen, still flows over time, not like rivers, but like glaciers. It reshapes the land beneath it. It remembers pressure and gives in slowly, like candle wax pressed under time. Water on Earth erodes, it sculpts, it carves canyons and shapes continents. But on worlds where ice itself flows, mountains can move without ever melting. This is a universe where phase means transformation, not just state, where ice is not always cold, and water can boil without heat. On Titan, Saturn's moon, you find lakes and rivers, but they're not made of water. They're made of liquid methane and ethane, chilled to minus 180 degrees Celsius. Yet they, like water, they run downhill. They pool in valleys. They rain from clouds. Here, water is ice, hard, unmoving, forming the ground itself, and methane becomes the sky's tears, the sea's mirror, the voice of the weather. It reminds you, water isn't a substance, it's a role, a molecule that cycles, flows, erodes, evaporates, freezes, and begins again elsewhere. That role is played by different actors: methane, ammonia, carbon dioxide. But on Earth, and in many places, water still reigns. The shape may differ, the warmth may change, but the cycle, the rhythm of phase, remains. And maybe, just maybe, life needs not the what, but the how. Maybe it's the cycling, the movement, the shifts between solid, liquid, and gas that give rise to complexity, that build patterns, that feed change. Perhaps what matters most is not whether the ocean burns or the glacier flows, but that something moves in response to something else. Heat becomes motion. Motion becomes memory. Memory becomes awareness. And awareness, like water, takes many forms. Somewhere in an ocean that scalds just below boiling, life may be floating in layers of density like pages in a book. Elsewhere, beneath a mile of exotic ice, creatures may dream without ever seeing light, using warmth from a planet's aching core to carry on. And on moons where nothing flows for 100 years, a brief melt might come from an orbital shift, bringing floods to lands that have only known frost. Everywhere, water, And the idea of water offers a lesson. That softness can hold strength, that change is more powerful than force, that even in burning or freezing, movement can endure. You lean back now, mind adrift, no longer asking where water is, but how it lives, how it tells, the temperature of thought, the weight of possibility. Because on some planets, the sea boils. On others, the ice slides like time. And in both, the story continues. Somewhere far, past the sunlight's final breath, a molecule waits. It drifts, weightless, in a sea that never knew warmth, in waters not quite water, where ice floats beneath liquid, and the sky is made of stone. And yet, something stirs. A charge, a bond, a whisper of chemistry, beginning to dream. You are here now, floating through a strange sea. Not Earth's gentle brine, but an alien tide. Dark, dense, rich with compounds. Your body would not know. This is not whole alone. It is a canvas of ammonias, methanes, hydrocarbons, long and tangled, drifting like seaweed in a world colder than thought. And yet, things begin to build. On Earth, life starts in warm puddles, in vents, in tides. But in these other oceans, beneath icy moons, on carbon-soaked planets, inside salty underground lakes, life may learn a different chemistry. It does not need sunlight. It needs patterns. It needs molecules that recognize one another, that bond in repetition, that make shapes which can fold and fold again. Polymers, chains, instructions whisper from atom to atom. You drift now beneath Europa's ice, past the fractured ridges where heat escapes in size. Here, hydrothermal vents may carry dissolved minerals, iron, sulfur, silicates, the raw ingredients of identity. These vents do not scream. They simmer. They sculpt heat gradients in cold oceans, inviting ions to dance. On Earth, this dance births life. In the shadows of our own deep sea, where sunlight never reaches, life thrives on chemistry alone. It feeds on reactions, not rays. It builds from hydrogen and methane, not leaves or breath. So it might here too, farther still, on Titan, Saturn's honey-colored moon, you find a different sea. Lakes of methane, rain that smells of gasoline, a sky thick with haze, and yet a kind of quiet logic in its cycles. Methane evaporates, condenses, falls, a mirror to Earth, but colder, slower. Here, life would not use water at all. It would build with carbon chains floating in cryogenic rivers. No proteins, no lipids, but perhaps something functionally the same. Membranes made of acrylonitrile, RNA analogs that slide like silk through liquid methane. Life, not as we know it, but as chemistry allows. You see now, life is not bound to one recipe. It is an emergent property, not of molecules, but of complexity. Given enough ingredients, enough motion, enough time, systems arise. The alien seas you wander through are not barren. They are ripe, not with cells, perhaps, but with potential. Now you journey to an exoplanet, a super Earth, orbiting a cool red sun. Here, the oceans are thick with salt, denser than any brine on Earth. The pressure is crushing. The water, laced with ammonia and carbon dioxide, never freezes, even at temperatures that would shatter steel. Yet the chemistry is wild. The molecules here form rings and loops. They self-assemble like puzzle pieces in slow motion. Perhaps they don't replicate like DNA, but they persist, and persistence is the soul of life, something that holds its shape against entropy, something that absorbs from its surroundings and leaves behind a changed environment. Not every world needs cells. Some may have filaments, ohms, films, webs of chemistry that pulse when heated or curl when chilled, a language of reactivity, a mind made of molecules that have never seen carbon the way we do. And yet, all life, anywhere, needs two things: a boundary and a process. The boundary keeps the self in and the chaos out. The process lets energy flow through the self to create structure. On Earth, that boundary is a membrane. That process is metabolism. But on Enceladus, or in the methane rains of Titan, or deep beneath Gliese 1214b steaming clouds, that boundary may be crystal, or foam, or a shifting electrical field that forms a loose skin of charge. The process might be redox reactions no Earth cell could survive. Still, they transform. Still, they persist. You close your eyes now and feel yourself dissolve into a molecule in a strange sea. You drift, a fragment of nitrogen and carbon, bumping into others in slow, sticky collisions. Then, a spark, a bond. You're now part of a chain, a structure with pattern, with memory. When heat rises, you fold. When cold comes, you stretch. Each state remembers the last. And in that memory, in that reversible structure, is the first hint of awareness, the first breath of life, not thinking, not yet, but cycling, reacting, persisting. There is a comfort here, even in the strangeness. Because though the molecules differ, the story feels familiar. The cosmos is not shy about repeating themes. It improvises. Life, it seems, is less a miracle than a tendency. When molecules are given time, space, and cycles of energy, they dance toward structure. And structure, long enough sustained, starts to wonder what it is. Now you rise again, leaving the warm alien tides behind you, carrying their questions like pearls in your mind. What counts as life? Must it breathe? Must it move? Or must it simply change? Change with purpose. Change with memory. Change that builds on itself until something new emerges. In these strange waters, where fire may freeze and ice may flow, life may not look back at us, but it may still look. The stars blink overhead, their light scattered by distance, by dust, by time. But in the dark between them, there are oceans. Oceans without shores, without skies, without voices. And yet, you listen. You float now, in a silence so vast, it becomes a kind of sound. The sound of waiting, of wondering, of listening for something that might call back. Not in radio, not in light, but in chemistry, in movement, in the rhythm of liquid worlds that may know how to think. On Earth, listening for life meant watching for a signal, a wave from afar, a pulse in the static. But here, you're not searching stars. You're diving into water, not just any water, alien water. Strange seas that stir with unseen tides, where molecules may hum beneath icy lids, beneath Enceladus, Saturn's brilliant moon. The ice crust cracks and heals, cracks and heals as warm water surges from a hidden ocean. The Cassini spacecraft, long gone now, once flew through those plumes, tiny geysers that sprayed into space, spilling salt, organics, ammonia, and hints of something more. What do you listen for when listening for life in liquid? Not voices, not language, but patterns, cycles, chemical rhythms that can't be explained by rocks alone. The dance of carbon chains, assembled not by chance, but by direction. The energy gradients across a vent, the way heat is spent with purpose. The faintest breath of metabolism. On Earth, we know these signs. We see them in sulfur-loving microbes deep below the sea. They do not breathe oxygen. They eat the chemistry of their home. They leave behind acids and waste and heat in a signature we now know how to read. So now, across the solar system, we listen, not for voices, but for chemical echoes. Imagine yourself, a molecule of life's first hope, tumbling through Europa's sea. You drift through briny water, past hydrothermal plumes, past silicate particles, past metallic salts, and then you find others, not by accident, by attraction, by design. You form something new, not static, not random, but persistent. That's what we listen for. Not words, but intentionality. We've built instruments that can sniff for life, though they never draw breath. Mass spectrometers ride on spacecraft backs, waiting for a gust of alien mist. They taste for complex molecules, amino acids, fatty acids, long carbon chains, with chirality and structure. It's not just what's there, it's how it's arranged. Because life, no matter where it stirs, prefers patterns that hold. But how do you listen for something you've never heard before? How do you recognize life that may have no DNA, no proteins, no cells? You open your mind to broader possibilities. On Titan, you look not for water, but for solvents that do the same job in colder ways. Liquid methane lakes could carry molecules that stick, that bend, that organize. Would such life be fast? No, it would be slow, lethargic, by Earth's standard. But even slow chemistry can evolve structure. Even frozen minds can think. So you listen not for time, but for trend. for the direction of change. Does the environment shift in a way that suggests feedback? Does something react, then adjust? Does a cycle repeat with variance? That's the heartbeat of a living system. Adaptation. You imagine now a pool of hydrocarbon on a faraway moon. To your eyes, still, but to itself, alive. It curls and uncurls its molecular skin, sensing changes in light, in charge, in composition. No eyes, no nerves, just response, just memory, written in structure. If it reacts differently the second time a stimulus comes, then it remembers. That's life. That's the whisper we're trying to hear. And what if it's deeper still? Not chemistry, but currents. What if alien life is a turbulence in fluid? A pattern that recurs only in the motion of water? Like a self-sustaining whirlpool that carries molecules in loops that organize them just enough to persist. Could a thought be a flow? Could a self be a circuit of temperature and salt? We don't know, but we're learning to ask. The James Webb Telescope scans the skies now with precision that feels like magic. It catches light that pass through the atmospheres of ocean worlds. It tells us what's in those clouds: steam, sulfur, ozone, even signs of methane and phosphine, gases we know on Earth can be linked to life. It's a kind of listening, but in light. Still, what's most intimate is in the liquid itself. To know if life swims, you must go in. So we build probes, not to fly, but to dive. Europa Clipper, Dragonfly for Titan. Future missions that will carry tiny laboratories into these oceans. They'll touch the waves. They'll sip the alien sea. They'll run quiet tests in silence, listening for imbalance, for preference, for life. And one day, we may not just listen. We may learn to speak. Imagine a future not so far where your voice reaches out to a pool of foreign liquid and it answers, not in words, but in a pulse, in a wave, in a slight shift of chemical hue. You won't understand it at first, but you'll feel it, a presence, a pattern, an other. And maybe then you'll realize that silence was never empty. It was just waiting to be heard. Darkness is not always empty, and blindness is not always silence. Beneath the ice, beneath the waves, beneath the reach of light, something stirs. Something that cannot see, yet knows. Cannot speak, yet listens. Cannot dream of stars, but may dream all the same. You're drifting now through one of these alien nights. Picture a world where the sky is stone, where no dawn ever comes, where light is a rumor from a faraway sun that never breaks through. This place is not barren. It is not lifeless. It is simply different. On Earth, we once thought life needed sunshine, leaves, photosynthesis, light to eat. But then we found the deep sea. Down there, in the blackness, life blooms in warmth, not light. At hydrothermal vents, giant tube worms sway. sustained not by rays from the sky, but by chemical fire from Earth's crust. Bacteria feed on minerals. Worms feed on bacteria. Crabs, fish, and blind eels glide between volcanic towers, never seeing, but always sensing. They are Earth's first alien life, our practice ground for stranger forms. So now, you imagine something similar, but farther, colder, older. Imagine Europa, where the ice shell is thick as mountains, but beneath it, an ocean churns. No sun has ever shone there, no shadows, no reflections, only warmth from the moon's own skin, heated by tidal squeezes, by gravity's friction. It is dark, but it is alive. What would life become if it never once saw a star? It would not need eyes. It would not paint its world in color. It would taste motion. It would feel charge. It would sing with molecules and listen for echoes in salt. On Earth, creatures born in the abyss develop strange gifts: electroreception, vibration sense, pressure mapping. Some can feel the flow of ions along another skin. Some can see by detecting current. This is not blindness. It is a different kind of sight. So picture now a creature in Europa's sea. It is not soft, not fragile, but elegant, streamlined by slow time, by cold evolution. It pulses gently as it moves. Its skin glows faintly with bioelectric lines, not to dazzle, but to sense. Teeny cilia along its flanks taste chemical gradients. Its body listens for density, salinity, temperature, magnetism. It cannot see you, but it feels you. And what would it know? Would it have memory? Perhaps not in a brain, but in a loop of proteins folded just so, in chemical cascades that respond differently after each encounter. You call it learning. It calls it change. Would it have culture? Not with tools, but perhaps with trail markers in ion fields left behind for others to follow. Kind of map, the kind of message passed not in words, but in waves. Now drift further to Titan, where seas are made of methane and raindrops fall like slow glass. Would anything live there? We do not know, but we imagine. Here, life would move through a cold syrup of hydrocarbons, not needing heat, only complexity. Maybe it builds shells of waxy molecules, floating like translucent boats. Maybe it sends ripples across the lake's surface to communicate in rhythms too slow for your mind to notice. Perhaps one wave is a greeting, two is danger, three means follow me. But how would you understand a creature that evolved in blindness, in silence, beneath alien nights? You start by listening, with machines, with mathematics, with patience. You look for patterns that repeat and evolve. You search for structure that resists chaos. You open yourself to minds that are not shaped like yours, because intelligence does not wear a face. It might wear a spiral, or a field, or a tide, and perhaps it does not move. Perhaps the mind is not inside a creature, But inside the sea, a planetary consciousness spread wide like a nervous system made of temperature and turbulence. It remembers in salt patterns. It calculates with convection. It dreams in current. And it may have never once known that it was alive until you arrived to name it so. Could you speak to such a mind? Not with grammar, not with sound, but with resonance, with vibration, with repeated action. A probe dips its arm into the sea, pulses a rhythm, and waits. A long pause. Then, from far below, a return pulse, not identical, but altered, considered. It may be nothing. It may be everything. A question, a reply, a beginning. You feel now how small your senses are, how much you rely on light, on sight, on voices. But in the dark, there is another kind of knowing, one that doesn't look, one that simply feels. You realize these eyeless creatures in alien nights might never understand you, but they might still recognize that you are alive. And you might recognize them too, not by form, not by sound, but by the shape of their curiosity and the rhythm of their reply. There is a kind of silence that only water knows, a deep, unshaken stillness pressing from all sides. No wind brushes its surface. No sunlight dances across it. No sky waits above. And yet, it breathes, not with lungs, not with air, but in some quiet rhythm, older than sky, older than sound. You are drifting now through that breathless sea. No gurgle, no splash, just pressure and motion and the slow ache of unseen tides. This is not Earth, and this is not death. On Earth, oceans breathe by the wail of the wind. Air tumbles down from sky to sea, dragging oxygen into water's folds. Waves churn, currents loop, and gills find their rhythm in this eerie exchange. It is a breath, you know. Inhale, exhale, gasp, whisper. But in the frozen reaches of the outer solar system, water hides beneath ice. There is no sky, no wind, no ripple at the surface. And yet, motion still stirs below. You close your eyes. Now open them. Beneath Europa's crust, miles of ice press above you, cold and clear and ancient. But underneath, an ocean, deep, salty, moving. Europa, moon of Jupiter, roughly the size of Earth's moon, but with twice as much water as Earth itself. And though the sun barely touches it, Europa shudders with each orbit, squeezed gently by Jupiter's pull. This stretching, this flexing, it warms the ocean from below, not in violent boils, but in slow pulses, like warmth rising from a sleeping stone. And with warmth comes motion. Thermal plumes rise, gently disturbing the dark, not like storms, but like breath held a very long time, and then released. The heat travels upward, carrying salts, carrying minerals. Layer upon layer of temperature and salinity begin to separate, and those layers begin to shift, to slide, to circulate. Currents are born not from weather, but from warmth and contrast. This is the kind of breathing that does not need lungs, a respiration of gradients, a circulation of energy. For in any ocean, life cannot cling to stillness. Water that rests too long becomes starved, depleted. Stillness is not peace. Stillness is death. But here, despite the cold, despite the silence, Europa's ocean stirs. It stirs enough to carry nutrients from rock to liquid, enough to feed chemistry that might become biology. And if there is life here, it must breathe in this strange way, without sky, without lungs, but not without rhythm. Now drift farther to a smaller moon, Enceladus, a moon of Saturn, and perhaps one of the most promising places to find alien life. You arrive at its south pole. Ice cracks wide open like old bark, and from those fractures rise plumes, jets of water exploding into space. A frozen geyser, but not just that, a breath. The water beneath Enceladus's crust is salty, warm near the rocky core, full of potential. As the moon flexes under Saturn's gravity, the pressure pushes water up through the ice, and now a kind of cryovolcanic exhale. And in those plumes are organics, salts, possibly even the building blocks of life itself. The seafloor you cannot see is speaking with every jet of vapor. It says, I am moving, I am mixing, I am breathing. Imagine standing on that icy plain, watching those plumes drift up into the stars. They rise silently, but with purpose, and below them, an ocean that never sees light, but never truly rests. Warmth seeps from the rocky base, creating vents, places where heat and chemistry collide. Just like on Earth, black smokers may dot the floor, vents that pour out hydrogen and sulfides, sustaining life without a single ray of sunlight. You recall now Earth's own abyssal plains, where blind shrimp gather at vents, where tube worms bloom in mineral heat, where life learned to breathe in the dark, not with oxygen, but with sulfur, not with photosynthesis, but chemosynthesis. If it happened here, why not there? Why not in Enceladus's night? In Europa's pressurized sea? Life does not need what we need. Life needs motion. Life needs difference. Life needs breath, in whatever form can find. And then your thoughts drift to Titan, bigger than Mercury, shrouded in haze. Its rivers do not run with water, but methane and ethane, liquid natural gas, in the freezing cold. Here, lakes ripple, not with tide, but with chemistry. Rain falls, but not from clouds you'd know. Evaporation, condensation, cycle, a breathing of carbon instead of oxygen. It is not the breath of lungs, but it is breath. Still, everywhere you look, the universe finds ways to stir, to circulate, to exhale. It does not wait for air or wind or sunshine. It invents its own lungs, its own rhythms, And those rhythms may carry something more than chemistry. They may carry life. You drift back toward Earth, not out of disappointment, but with awe. You remember how life began in Earth's oceans, not on the shore, but in the deep, in places where heat bubbled up from below, in places that had no air, no sun. And now you wonder what breaths might rise in oceans we have never seen. It begins with a drip, not a crash, not a flood, just the soft sound of something solid becoming something else. A glacier breathes out a slow tear of water, and in that moment, a memory is released. You are standing now at the edge of a melt, not Earth's, but somewhere stranger. A frozen moon, an ancient shell, a world wrapped in silence and waiting. What melts is more than ice. What escapes is more than water. It is a message. On Earth, glaciers hold stories. They trap bubbles of vanished skies, trace gases from forgotten seasons. They remember volcanoes, wildfires, even the breath of long-dead forests. They are not inert. They are archives. Pressing weight writes time into their layers. But when they melt, they speak. And elsewhere, on moons and icy planets, alien glaciers may whisper too. Imagine a moon like Callisto, Jupiter's battered child. Surface cracked like an old ceramic plate, but deep beneath, layers of ancient ice, untouched for billions of years. A frozen crust, 100 kilometers thick, and within it, impurities, trapped gases, salts, dust, organic shadows. It is not lifeless. It is paused, and as it begins to warm, by impact, by tidal stress, or by the slow breath of time, it releases. It melts, and when it does, it tells. Drip by drip, the ice lets go of what it held. Molecules preserved from the formation of the solar system. Perhaps even the fingerprints of prebiotic chemistry in that first thin stream might be a nucleotide, a fragment of a sugar, a carbon ring etched by time. In the melt might be memory, and in the memory, a message. I was here. I tried to become something. Now move to Pluto. Far beyond warmth, this dwarf world was one spot, still and frozen. But beneath its nitrogen glaciers, there may be movement. Sputnik Planitia, a vast plain of ice, shows signs of convection, of churn, and that means change. Perhaps beneath its deep crust, a subsurface ocean still stirs, and in the melting of Pluto's ancient frost, complex molecules, once shaped by cosmic rays, may now mix, move, migrate. A chemical thaw, a quiet reckoning. You're floating now near Ceres, largest body in the asteroid belt. It once held a briny ocean. Now, the salt stains remain, like ghostly veins on its surface. But deep below, water may still be melting. In places of impact, where heat blooms briefly, old ice softens. And from that melt, something rises. Hydrated salts, carbonates, even ammonia, a possible antifreeze in alien seas. And what if, in that melt, a structure lingered? Not alive, but promising. A chain of molecules that just needed one more stir, one more jolt to begin something new. On Earth, we once believed that cold killed, but we've learned that cold preserves. In the permafrost, viruses sleep for thousands of years. Revived by sunlight or meltwater, they wake as if no time had passed. Could alien ice do the same? Could a moon's glacier hold not only chemistry, but potential? The blueprint of a life, never born, or born, but buried. And now, a comet, a drifting archive of the early solar system. As it nears a star, its surface begins to melt. Gases stream away. Ices sublimate, trailing a tail across the black. But within those gases, we detect something familiar. Glycine, formaldehyde, simple sugars, pieces of the great molecular puzzle. The comet says, I have wandered, I have waited, I have carried your origin on my back. Its melt is a message flung to any world that might listen. Perhaps life begins with these messages, not as lightning strikes a puddle, but as ancient frost softens in the right place at the right time. A molecule trapped in one ice grain meets another as they both drip into warmth, not fate, just timing, just melt. The ocean doesn't start with waves. It starts with thaw. Think of Europa again. Its plumes rise from below the crust. In each one, a mixture of salts, water, and maybe, just maybe, the memory of cells, or the potential for cells to be written. A library boiled into steam, spraying out into space. What if we could catch that mist and read it? What if melt is not just water, but a text? Not all messages are written in ink. Some are written in temperature, in pressure, in salt, the shape of a molecule, the twist of a strand, the ratio of carbon to nitrogen to hope. To read these messages, we do not need eyes. We need instruments that can taste the ancient flow of time in frozen veins. To understand melt is to understand what was and what might be. And so you float again in the dark with stars above and ice below. Every frozen world said, I remember. Come melt me. I will show you what I saw. And some may whisper, I dreamed of life. I almost became. Drip by drip, the universe unseals its secrets. And you, a small listener, begin to hear the first syllables of that long, slow language. Beneath the crust, beneath the pressure, beneath the silence of distant moons, a mirror waits, not of glass, but of liquid, dark, moving, alive in a way we don't yet understand. Not a reflection of face or form, but of essence, of patterns, of choices unmade, of life perhaps, not as we know it, but as it might be. This is the mirror in the deep, and when we gaze into it, we are not alone. Far from earth, far from sunlight, oceans ripple beneath ice shells. miles thick. They are lightless, but not lifeless. Still, but not silent. Within these alien seas, currents stir softly, bearing with them more than just salt and heat. They carry questions. They carry echoes. They carry the possibility that something is looking back. Imagine Europa, a glassy moon, its surface scarred by tides of invisible force. But beneath that frozen skin, an ocean. An ocean as wide as Earth's, perhaps deeper. And in that ocean, minerals fall from hydrothermal vents, jets of warmth in the dark. Just like home, just like Earth's own origin place. Could a spark catch in that deep, dark water? Could patterns form that remember how to move, how to sense, how to survive? Could Europa be holding a mirror to Earth's ancient past? Now imagine Enceladus, small, cold, and yet it sings. Its icy geysers spray into space, casting mist that's rich with mystery, salts, organics, traces of heat. It is as if the ocean beneath wants to be seen, and in its plume, maybe a trace of something that built itself. Something simple, but intentional, not an accident of chemistry, but a choice, a message that says, I too have mirrored your path. The mirror in the deep doesn't show you what you look like. It shows you what else could have been you. If water was just a little warmer, if molecules shuffled a little longer, if time was kind, it shows you what life might be if it didn't need sunlight, if it didn't walk or breathe or bloom. Just drift, just know, just be. We once believed life needed air. We now know some life never needed it. Earth's own microbes live in boiling vents, under crushing pressure, in methane lakes, in acidic pools. Life here has already shown that it can exist without a sky. So why not elsewhere? Why not beneath the sealed vault of Titan's crust, or inside the quiet brine of Ganymede's heart? The mirror reflects not only Earth, but Earth's imagination. It asks, what if your version of life is just one of many? We peer into these oceans, not with eyes, but with instruments, radars, spectrometers, robotic scouts, scratching at the ice. But what we are really looking for is recognition, not a hand, not a voice, but a rhythm, a chemical cadence that whispers, I too adapted, I too learned. And in that moment, if it comes, we will see ourselves in what is most alien. The mirror may lie in Titan's lakes, rich with methane, cold enough to freeze breath, yet still liquid. What swims there, if anything, would be unlike us in every way, non-water-based, perhaps silicon-born, a mirror from a parallel chemistry, not the image of our bodies, but of our inventiveness, of nature's wild capacity to try again and again until something pulses. In these oceans, time is deep. Earth had 4 billion years to try its hand. These moons have had just as long, and under thick layers of insulation, they may have changed slowly, stealthily, inwardly. No continents, no atmosphere, just water and rock interacting in the dark. A petri dish with no eyes watching. Until now, if life exists here, it may not care about us. It may not even notice. It may simply flow, replicate, consume, divide, die, begin again. But in doing so, it fulfills the same drive that animates all life to persist, to be, and that is where the mirror shines brightest. Maybe we won't find creatures. Maybe we won't find anything we'd call alive. But even then, the chemistry of these oceans will speak. They will tell us how far nature can go before becoming life, where the edge lies between chaos and code, between soup and soul. And that, too, is a reflection, a mirror showing the boundaries of the possible. The future may bring robots that dive beneath the ice. They may glide through alien waters, sampling, recording, listening. And maybe they'll see a shimmer, not from sunlight, but from movement, from something that turned and swam away. Or perhaps they will find silence, but in that silence, the ingredients of a story never told. The mirror in the deep is not waiting to be found. It is simply there, as it always was. What we see in it depends on what we're willing, understand, to let go of Earth as the only blueprint, to welcome a second Genesis, not of us, but of something new, beneath the surface of a moon wrapped in silence. A slow ripple begins. It does not shout, does not gleam, does not glow with eyes or flame, but it moves. It glides gently through salt-thick shadows, stirring the quiet like a breath from another age. Not a wave, not a storm, but perhaps a swimmer. Could something be swimming now? As your body settles into stillness, as breath becomes slower than wind, another world turns. Far away, cold, dim, but alive with motion. Europa, the icy moon of Jupiter, spins softly through its orbit. Beneath its frozen armor rests an ocean, not imagined, not guessed, confirmed. Liquid water, salted and stirred by the giant's tidal pull. An ocean sealed for billions of years, warmed not by sunlight, but by the flexing of rock and time. Imagine it, an entire ocean locked under ice, thicker than mountains. No skies, no storms, only the gentle push of warmth from within. The rock beneath, cracking and shifting, releasing heat, releasing minerals, releasing the possibility of life. For life needs three things: a solvent, a source of energy, and enough time to experiment. Europa has all three. And time. Europa has plenty of time. What could life be without a sun? Without photosynthesis? Without leaves? Or light? Or the color green? Life might begin with chemistry instead. Tiny molecules drifting in the water, bumping, bonding, becoming something new. A self-copying strand. A bubble that divides. A system that refuses to stop existing. Not intelligent, not even aware, but alive. Maybe they gather near warm cracks in the crust around hydrothermal vents, like those deep in Earth's oceans. We've seen life on Earth's ocean floor, where no light ever reaches. Worms with no mouths, crabs with no eyes, microbes that feast on the energy of the earth itself. These life forms don't care for sunlight. They live off the chemistry of the deep. Why not Europa too? Now drift further out to Enceladus, a small moon of Saturn, icy and bright, cracked like a shell and breathing vapor through its southern pole. Its geysers, plumes of ocean water shooting out into space, have been sampled by passing spacecraft inside them. Salts, simple organic molecules, and perhaps even hints of complex ones. These are not accidents. They are clues, whispers from an ocean we haven't yet touched. Imagine what swims there. Not whales, not fish, not anything that would swim beside you, but microbes, mats, tangles of living filaments clinging to warm stone, or single cells drifting endlessly on slow ocean tides. They may react to heat, to chemical gradients. They may cluster together for warmth, for food, for exchange. They may grow, and they may die, and they may begin again. Life, even here, would be shaped by the same forces that shaped us, not by light, but by need to continue, to respond, to endure, and change. And so they adapt to darkness, to pressure, to silence, stretching miles deep. But what if they evolved further? What if, over eons, they began to sense, to swim not just blindly, but with purpose? Could they communicate? Not in sound, but in shifts of salt, in pulses of heat, in slow dances along the under ice current? Even now, on Earth, bacteria do this. They signal, they coordinate, they know, in some quiet way, when they are not alone. And what of Titan, the methane world? Its lakes glisten, not with water, but liquid hydrocarbons. Yet even there, complex chemistry dances in the air and drips into the dark. Life could evolve, not in spite of the cold, but because of it. Slower, stranger, more delicate, built of different rules, living on the edge of everything we know. So the question lingers, not could life have existed, but is life unfolding now, at this moment, as you rest, as this story reaches your ears? Could something alien be stirring in that unseen sea? Not fossilized, not past tense, but present, awake, enduring, a second origin, growing in silence. What would it mean if we found it? If one drop of Europa's ocean held a creature not made of earth, not from your sun, your air, your dust, but from something else? Would we still call it alien? Or would we call it sibling? It would change not only our science, but our solitude. No longer alone, no longer unique. Just one expression of life's deep hunger to exist wherever it can. Already, missions are being planned. Robots that will fly, land, drill. Some may one day swim beneath the ice in search of motion. And if they find it, if a light flickers, or a sensor detects a twitch, or a molecule seems too organized to be chance, we will listen, and the stars will feel smaller than they did before. So, tonight, as your thoughts float between planets, as the dark folds like a blanket around you, imagine a ripple in a far-off sea. It does not call, it does not hope, but it exists. And that might be enough. And now, the stars quieten, the waves grow still, and your thoughts float softer than before. You've traveled far tonight, through oceans unseen, beneath skies unformed, listening for the whisper of life in the dark. But this moment, here with your breath, your heartbeat, your wonder, this is part of the universe too. You belong in the story of stars, in the silence between suns, in the question that never quite closes. So close your eyes, gentle dreamer. Let the galaxies spiral through your sleep. Let the unknown cradle you kindly. Good night, sweet dreams, and thank you for drifting once more with the dreamy physicist.